In this session, let's discuss about CCP module in PIC18. CCP is nothing but C stands for capture, C stands for compare, and P stands for PWM. In order to provide this particular capture, compare, and PWM is a kind of peripheral which simply allows the user to time and control with the different events. More specifically, when you talk about capture mode, this particular capture mode will simply provides access to the current state of the register, which is constantly changing its value. In this case, usually timer 1 registers are used. In that manner, it will simply capture the current instance of time with the help of timers. That is nothing but the capture mode of your CCP module. Another part for this CCP module is compare. Now compare mostly compares the value between two registers. So in order to that, one of them is the timer register, and it will simply allows the user to trigger an external event whenever it is been predetermined amount of time as whenever it is expired. So in that manner, you will say that this particular event generation on the basis of comparison of two values altogether and producing the event. And the third category under this CCP module is PWM. So PWM is nothing but pulse width modulation. So you can generate signal with varying frequency and duty cycle. So in that manner, these kind of application can be utilized wherever the varying time period is mentioned and required. With the variable duty cycle, you can go for the PWM module. So in PIC18 F4550, it has two CCP module, CCP1 and CCP2. Each module contains 16-bit register, which can operate as a maybe the 16-bit capture register or 16-bit compare register, or even for that matter PWM. Now in that manner, this particular CCP utilizes timers. So in that way, the timer 1, 2 and 3 will be utilized depending on the mode of the particular CCP module is being selected. Out of that, timer 1 and timer 3 are always available to the module in the form of the capture or even compare modes. So in that manner, you can say that these two will be utilized either in the form of capture mode of operation or compare mode of operation. Whereas for timer 2, which is exclusively used for PWM mode. Now let's discuss how this particular CCP module will thoroughly react upon for the capture mode. So as I have told you that capture mode will simply provides the access to the current state of register, which constantly changing its value. So in this case, let's say timer 1 register is used. So in that manner, this particular capture register will be the part of the 16-bit register value CCPR1, which will consist of the CCPR1L and CCPR1H register. So all the time, this particular capture event will be on the basis of it is used for capturing the data with the binary numbers that are stored with the timers, maybe in the form of timer 1 or timer 3. So in that way, whenever you are using this timer 1 and timer 3, the associated timer count is loaded in lower byte of that timer register and higher byte of that timer register. Maybe if at all it is timer 1, then this number will be placed as a 1, and if at all it is been 3, timer 3, then same timer count register can be denoted with the register name TMR3L and TMR3H. So here the CCPR1H and CCPR1L, this is nothing but 16-bit register, and this particular register is associated with the lower byte register and higher byte register of size 88 bits. So this is nothing but module registers required in your CCP1 under the capture mode. So in this mode, timer 1, that will be maybe the timer 1 and timer 3, that may be comprising of these two register, lower byte and higher byte. It will simply copy the data to this CCP1 register. So this CCP1 register, 16-bit register, that split into the lower byte as well as higher byte register. So in that manner, for every falling edge or every rising edge, or for even for that matter for every 4th rising edge and every 16th rising edge, these particular situation will get copied on the basis of this particular CCPR1 register. So the combination of this particular condition will be based upon the combination of 4 bits, that will be depending upon the what kind of mode of operation is required for your CCP, and based on that it will decide the particular mode of operation for it. So in this capture mode, CCPR L and H register, that is a pair which is required for the 16-bit value to get loaded from your timer 1 or timer 3. So when event will occurs, on that basis corresponding to that event, the predefined value will be followed, either of the every falling edge, every rising edge, or even for that matter every 4th rising edge or every 16th rising edge. So the event is selected by upon the mode select bits. These mode select bits are 4 bits which resides in this register, CCP1 con register, which is nothing but capture compare PWM 1 register, and that with con is nothing but control register. So as I am repeatedly telling that in PIC18 2 capture modes are there. So one signifies CCP module number 1. So in this control register, you will able to find the specific event generation based upon the following, maybe the every falling edge, rising edge, 4th rising edge and 16th rising edge. Based upon that, it will generate events. So that selection is under this particular control register. Even for that matter, for the every rising edge or for every falling edge, so in that manner the clocks are defined. So that's why this is falling edge of the clock and this is rising edge of the clock. So this is the more significant meaning of this particular clock signal applied for this edge detect. And whenever these kind of events are generated, this particular interrupt flag will get updated. So it must be clear in the software before setting it to 1, and this will get automatically set to 1 once the event will be generated. If another capture occurs, then before the value of this particular flag, we should clear it, so that for the next new capture event, this particular flag will be raised to 1. Now, just take some kind of concluding remarks in what manner your capture mode will work it out. So as I have told you, capture mode is more specifically associated with the timer 1 or timer 3. So initial timer 1 or timer 3 are initialized to the count value that is required in your capture operation, that must be loaded in either timer 1 or timer 3. Now, in that manner, if at all you wanted to use with the respect of timer, you have to utilize again control register that are required for that timer. So, if at all timer 3 is there, then T3 con register is used for selecting the respected timer for utilizing this particular capture mode, which is shown in this particular slide. And whenever the rising or falling edge that will get detected upon this particular CCP1 pin, it will generate the interrupt flag, and it must be cleared before setting up as and when the event will be generated. And when interrupt occurs, in that manner the value of that timer that will get copied into this particular CCPR1H and 1L register. So in that way, by looking upon this particular value stored in these two registers, it will be able to find the arrival of that particular time event, and it will generate the interrupt based upon the completion of that particular capturing mode. Now, to program this particular capture mode, you require CCP register. So in that manner, very first register, that is nothing but CCPR1 register, and this is 16-bit register, and that is split into 8 bits. So lower bytes and higher bytes. So 8 bits are associated with CCPR1L, and upper 8 bits are associated with CCPR1H register. Another control register is required. So in that manner, this control register is 8-bit register. Out of that, lower 4 bits are nothing but mode select bit. So as I am repeatedly telling you that these mode select bits are nothing but the mode selection. So based upon that, if you place all 4 bits as a 0, 1, 0, 0, so it will enter into capture mode at every falling edge detected. So for this particular diagram, this control setting mode selection bit you have set for every falling edge of this clock. So in that manner, every falling edge it can able to generate events for capture. Otherwise, few more options are there, like 0101 means capturing event for every rising edge detected. So this is falling edge, this is rising edge, or even fourth cycle rising edge can be detected, and you can generate event by placing these 4 bits as a 0, 1, 1, 0. If at all you wanted to look for 16th rising edge clock detected, in that manner you have to place 0, 1, 1. This will be your mode select. After that, fourth bit of this register and fifth bit of this register is 2-bit field, and this can be utilized for the compare as well as PWM mode only. So there is no place for capturing event for these 2 bits under the capture mode. So these 2 bits you can utilize either in your PWM mode, or you can utilize this in the compare mode. So this was all about capture mode. Now let's discuss about compare. Now the name itself is telling you that compare. Compare is nothing but comparison. So in that manner, always have the comparison between two values. So as per this diagram, this comparator will able to compare two of the values altogether. The value to be loaded in TMR1 register as well as the value to be loaded in CCPR1 register. So these two values are getting compared constantly. And whenever match will occur, it can generate the logic sequence. So in that manner, the sequence of that comparison will get generated, and based upon that you can generate the event at the RC2, maybe in the form of CCP1 pin in your PIC18 controller. And simultaneously, while doing this comparison, it will not only to check the comparison between two values, but also it will look for whether the interrupt will be generated or not. So there is a simultaneous event generation based upon the comparator comparing these values, producing one certain output logic sequence, and on the basis of that it will generate the completion of interrupt flag. Third mode of operation is PWM mode. Now PWM mode is nothing but pulse width modulation. So your width is not fixed. It is under the varying mode. So signal of varying frequency and your duty cycle may have your lot of wide application in the automation. So in that manner, you can say that if you place this particular logic 0, that will indicate as a switch off state. And if your logic 1 is 1, then logic state is 1, then it will indicate as switch on test with the variable duty cycle. So whenever I am saying this as a variable duty cycle, it may happen that maybe it can produce up to the 10-bit resolution output for your PWM, and it is more specifically multiplexed with the CCP2 pins, and that can help you out to provide this particular pulse width modulation wave with respect to the CCP mode. So in that manner, every time this PWM period will be specified by writing value to the PR2 register. So in that manner, PR2 register is associated with PWM period, and that period will get compared with the value to be loaded in the timer. So in that way, you can always look upon for the comparison, and then you are able to produce the output sequence at the output pin RC2. Now in PWM mode, certain calculations are required to perform for your PWM period for the respected duty cycle. So there are 4 steps for your PWM desired operation. So all the time, what you have to do is you have to first calculate PWM period. Now this period will be calculated on the basis of PWM frequency. So you will performing 1 upon frequency will give you the PWM period. And this frequency is not system frequency, it is PWM frequency. After this, you need to look for your oscillator frequency. Now this frequency will be nothing but your system frequency. So in order to that, for the system frequency, we need to generate the time period. So TOSC equals to 1 upon FOSC. So after getting 2 of the periods, one for PWM period and one is for your system frequency time period, after that you need to calculate PWM on the basis of writing the specified value to be loaded in PR2 register. Now this particular PWM operation is associated with pre-scalar value. So this pre-scalar may able to increase and decrease the certain period for your PWM. So for that matter, the third equation will be to calculate this PR2 value to be loaded in your PWM calculation. PR2 equals to PWM period upon 4 into TOSC multiplied by TMR2 pre-scale value and everything minus of 1. So to complete one simple operation of that particular PWM period, it will take it around 4 clock cycle. That's why this number 4 is mentioned under it. So on that basis, you can able to evaluate PR2 value, and now for this particular given period, you need to calculate the PWM duty cycle. So this particular duty cycle is nothing but, let's say in these two register, these 2 bits you have to load this particular PWM mode. But these are the only 2 bits. So in order to that, in your calculation, to calculate your duty cycle equals to percent of your duty cycle multiplied by FOSC upon 100 multiplied by frequency of PWM multiplied by TMR2 pre-scalar value. Because here we are taking frequency, system frequency. That's why here we are able to write the PWM frequency. Otherwise, if at all it would have been converted into time period, this equation will be little bit different than right now it is shown in front of you. Because as you know, FOSC is nothing but all the time 1 upon TOSC. In that manner, this equation becomes different in that basic mathematical formulation. Now, on that basis, the whatever value or whatever answer you will able to derive it from your duty cycle register. Now, it must be, as I have told you, your PWM period is 10-bit resolution. Means answer is 10-bit. Out of that 10-bit, 8 bits are loaded under this particular CCP1 con register. 2 bits will be loaded in CCP1 con register. Remaining bits will be loaded in CCPR1L register. Maybe in the form of L register or maybe in the form of H register. So more specifically, this register requires 2 bit and this register will be loaded with the 8-bit data. So in that manner, the answer, whatever you will able to get after the calculation of duty cycle, lower 2 bits are loaded here in CCP1 con register. Okay, so PWM duty cycle is specified by writing CCPR L register value along with CCP1 con register. So then and then only your actual PWM 10-bit resolution will be loaded. So this is simplified diagram for your PWM mode. Now comparator will be there, but this comparator will be comparing the value to be associated with your timer 2 register and PWM period. And even for that matter, again the comparison has to get taken place for the duty cycle generation, which is being associated with CCPR1L register and lower 2 bits of CCP1 con register. So like that way, again it will provide the logic for set as well as reset. So in that manner, to turn on the state and turn off this particular state based upon your PWM mode, these 2 comparators will help you out to compare the values of that respected timer 2, which is nothing but free running frequency, that is considered in terms of FOSC divided by 4. And that we have assumed it, that we have considered it in the PR2 calculation. So with the reference of this, you will able to generate the set and reset of the event at respected pins for the PIC18. So this is simple PWM mode application. Let's say here I have set duty cycle in this manner. This is on period. this is off period. Again, this is on period and this is off period. If I wanted to connect these kind of PWM application to glow any kind of lamp, in order to that, if you look upon for this duty cycle, the on period is less than that of off period. So the status for this lamp will remain off, and for the moment of this particular event of 1, for that moment only this light will be turned on. So this is more than 50% duty cycle. Here is the on period and off period are equal. So you can say that this lamp will be turned on for X time delay, and it will get turned off for again same time period. So on period as well as off period is same for this timer under this mode. And whereas in your on period is more and that of your off period opposite of this. So you can say that your light will be on for more duration of time than that of the off state for this lamp. So this is simple PWM mode of application, and you can utilize this PWM mode under the PIC18 resistor for various applications, like wherever you are utilizing variable frequency and time period, you can utilize this CCP module.